We're at ISE 2025 and we're launching Pixel IQ. To tell you more about it, I'm here with Liam Winter, Midwich's and PSCo's head of LED. Hello, Liam.
Hi, Jenny.
Tell us, what is Pixel IQ?
Well, Pixel IQ is something that we're working really hard on for a number of months now. I think as we've seen the LED display industry flourish and grow over the last 10 years, the one thing you can say about it is the platform has a lot of choice. There's a lot of options out there. PSCo Midwich, we're very proud that we represent a number of the leading brands within that space. Our brand portfolio features Samsung, LG, Sony, Sharp NEC and Absent. And then there's subsets of that. There's processing from Novistar and Brompton, and then we've got mount partners like Peerless and BTEC and Chief. So we've got a lot of choice, and the technology platform itself by design allows you to select a lot of different options suitable to the application and your budget for your project. So as a business, we've been servicing our customers, seeing their businesses grow, selling more and more LED solutions to customers, finding it's the right technology platform, and putting great demand on us to actually support them. And at the same time, they're coming to us for our expertise to understand what the options are. And we've had to do a lot of manual work to keep giving them those options and presenting that technology and all of those choices to them. So Pixel IQ is about making that more streamlined, making that easier, making that better, making it faster. So Pixel IQ is an advanced LED configuration tool. It will launch as an online configurator that our system integration partners, our consultants, and ultimately their end users have access to. And it will allow them to quickly look at all of the brands within our brand portfolio and draw technical comparisons between them, and ultimately quickly start trying to find the right display for them. They'll be able to configure that and get information on them and compare those choices. And then at a press of a button, they can drop that into the PSCo technical specialists, the LED specialists, where they can pick up and run with it and then scope out that solution. So you'll be able to have your LED display, different processing options, different mount solutions, and we can output a full technical proposal down to a level of data wiring, power consumption, full CAD drawings, even the mount displays. Put that into a technical sales package with the marketing and materials from the manufacturer to actually sell the technology. And then a line item quotation that actually scopes out everything you'll actually need to make it work, to deliver it. In addition to that, PSCo's value-added services will be available to partners as well if they need support with delivery or post-sale support. And also it means that they're quickly going to be able to have all of that information on tap. And it's going to help them really streamline their sales process with their client. And what you can find with LED, and I find this all the time, is people in those early stages, they are trying to understand what's going to work for them. And sometimes it can actually feel a bit of a burden to have the choice. And we want to get that out of the way and actually say that's part of the power here. With Pixel IQ, it's got the intelligence to only specify technically accurate solutions for you. And actually choice is a thing. And you should lean into it and help your client find really what's the right LED display for them. So yeah, we're very excited by it. There's been a lot of long days and dark nights, making sure all of that information goes in so that it's accurate. But yeah, we think it's going to be a real game changer for our customers. So we're looking forward to it launching at the show.
There's a lot of acronyms and jargon in this category. Can you talk us through, in the simplest of terms, the different technology types that are available, from what we see traditional technology through to chip on board, and how that's moving now, and what you think are the technologies of choice currently?
The technologies of choice. Ultimately, there's three types of LED. One is the very early original technology, which is called DIP LED. That's your traditional LED diode, a discrete inline package, and really that's been phased out by SMD LED for a number of years, and it's only used in very large-scale outdoor high brightness applications.
Right.
So really that technology is sort of almost boxed up and packaged away in an outdoor environment, and it isn't the dominant technology anymore. Surface mount device, LED, basically took the LED chips and made them smaller and packaged them into a device that could be soldered on to the driver board and allowed us to get the pixel pitch smaller.
Okay.
And that's really what's driven the growth of the LED platform.
Yeah.
The challenge with a surface mount device technology is there's only so far you can go to make it smaller, to get your pixel pitch smaller, to get higher resolutions and increase your viewing, shorten your viewing distances. And the technology is relatively fragile in that the pixels are exposed on the surface. So that has been, over the last 2 or 3 years, there's been a huge growth in what we call MicroLED. And MicroLED has a number of different names. Technically, most MicroLED is flip chip on board.
Say that slowly.
Yeah, so flip chip on board. So you've got a red, green and blue pixel.
Yep.
It's a semiconductor chip. It's an LED chip, and you put power into it and it will emit light. And normally we put that chip into the little surface mount device and solder it to the driver board. With flip chip on board, you take the chip and you place it directly on the driver board, and then you coat the surface and encapsulate it completely. So there's a number of benefits for it, but primarily it allows you to have a higher brightness, higher contrast ratio, wider viewing angles, wider color gamut, lower power consumption, lower heat. And the surface is protected from the elements, so you can knock into it and you won't break it. And also you get a certain level of ingress protection for humidity, water, dust, etc. So really, flip chip on board based MicroLED technology is going to be certainly below certain pixel pitches, indoor applications. It's grown massively sub 2 millimeter. It should primarily be the only technology of choice under 1 millimeter, really.
Right.
It's the most compelling under 1 millimeter. And it's the one that's driving growth in the high resolution category. It's not to say that SMD is dead. It's still got some advantages in certain applications for the technology, and in some of the larger pixel pitch categories, or where you're on a budget and the chip on board can sometimes be a bit more expensive as a solution. So yeah, your choice really, if we're talking indoor LED and we're not going into the super high bright outdoor, is an SMD or a micro LED.
What about the term glue on board?
So glue on board is a form of SMD.
Yep.
So you take your SMD, you place it on the board, and then you coat it. So its technical term is actually coated SMD. But because people wanted you to feel like glue on board was chip on board, they kind of spun COB and called it GOB.
Gob.
Or GOB, yeah. So I've never been a huge fan of GOB. There are certain applications where it can give you a higher level of physical protection and ingress protection at a price point, but it comes with a lot of compromises.
Okay.
The chip on board application, the technology is the best way to do it, if you can get it.
And you've referenced MicroLED. There's also the term MiniLED that gets thrown around. What's the difference between the two, and how often are people mixing them up, perhaps?
All of the time, and rightly so. We to an extent, we play the marketing game ourselves. We choose to call flip chip on board MicroLED because I always say, if I bring my mum into our Innovation House Experience Centre and start talking about flip chip on board, she'd have left in no time. Whereas if you say, I'm going to show you MicroLED, I think people can connect with that phrase. It sounds great. It sounds like new technology. It's good. So Mini LED, normally Mini LED is referred to as a 4-in-1 IMD SMD. So it's taking an SMD package and putting 4 into 1, making a larger surface mount device. And there are some benefits for that, but that's quite niche in its application now, the IMD SMD. There is another one as well, which is called MIP, which you may or may not have heard of, which is micro LED in package. So it's taking a micro-sized chip size, and it's packaging it into a surface mount device, and then it's coating it. So it's kind of a form of micro LED that will also be a kind of another technology trend. And and it allows the LED manufacturers to do something a little bit different with the technology. But yeah, that's the core differences between the naming.
So we've seen a lot of the manufacturers, particularly those that came from the LCD space and have moved into the direct view LED space, release all-in-one solutions, i.e. you come to them, you want a 130-inch display at a specific resolution, and you have a ready-made kit list to buy. Obviously, Pixel IQ allows us to be more fluid with our requirements, perhaps not so rigidly aligned to specific sizes. What percentage of business do you think are looking for that predefined all-in-one LED offering versus the I've got a space, what can I do with it client?
Yeah, I understand. It's grown massively, that category. It's been growing a long time. And ultimately, a lot of the time it's about your content and what you're trying to present to people. And most of the time, if you're going to present a PowerPoint from a laptop, ultimately, your laptop's a 16:9 aspect ratio content output. So having a full HD or a 4K canvas in the 16:9 aspect ratio really works. And a lot of the time, people have been using LCD technology at smaller size. They've had their content produced for signage applications in a 16:9 aspect ratio, and they just want a bigger version of that. So again, the all-in-one works really well. If you'd asked me a few years ago, it was a small part, and not many manufacturers had it. This time last year, we were launching 14 new all-in-ones across 5 manufacturers. And that category's only kept growing this year, and you'll see more of them. The benefit is that if you know that's what your client wants, you can get some efficiencies into the manufacturing process that package up that technology in a better price point.
Yeah.
They make the installation faster and easier for the client, which brings the cost down as well. And ultimately, they can start building in the actual all-in-one, which is elements like touch technology or audio built in or screen sharing solutions, or being able to just plug your HDMI directly in and sort of cut out the LED processing complexity of the solution. So I would say that at the moment, it's probably about 40% of the LED business that we're doing. But the sort of any size fill the room stuff is still the biggest part of our business.
And what about use of LED technology? So we've seen a shift towards broadcast use cases. There was a lot of noise about virtual production and XR studios for a while. What are the key categories, key vertical markets for direct view LED?
I mean, in terms of growth markets, the virtual production application, just a continued growth in the use of LED as a backdrop for broadcast applications. But we've seen that for a long time in your TV studio application. A lot of the growth has been in corporates wanting to make an investment to be able to create their own content.
Right.
Because we live in a world with maybe not TikTok in America, but your TikTok, your YouTube, those kind of platforms where people want to see content all the time.
Yeah.
So people, the wider ecosystem of broadcast technology has got simpler, easier, more cost effective. So even this kind of mock studio we're in today is an example of that. And having LED as your backdrop for that is a really good platform. Yeah. It works really well in camera, super high refresh rates, great uniformity, etc. So we're seeing a growth in those applications. Virtual production for movie production, for high-end TV production, for advertising production in particular as well. It works really well there. So I'm not going to say green screen replacement, because I've spoken to enough experts that know way more than me about virtual production that it's just another tool. It's another production technique. Yeah. It's not going to delete green screen or going out into the real world and shooting on location, but it can be a really powerful solution. So actually over the last year, the biggest growth for that market has been higher education, which kind of makes sense. There's a pull from the market. They understand that there's a benefit to the technology, and they now need people to have been trained and learn from that. So we have had studios as well in the UK that have invested. A big film studio we've just won actually very recently. So yeah, they're big growth areas. Also visualization for LED as well. So more and more people wanting to do product design on a canvas in real time with their CAD engines and be able to visualize their products and their technology. And LED is a great platform for that with its image detail and image quality. And particularly now with the MicroLED and smaller pixel pitches, allowing them to have more detailed canvases and get much closer to the screen. So
where are we at with pixel pitches? So what's the lowest available pixel pitch from any of our manufacturers?
It's currently a 0.6 millimeter.
Interesting.
Commercially. But ultimately, that's not a huge seller.
Okay.
If I'm totally honest.
At what size can we achieve 4K or UHD resolution with that pixel pitch?
0.6 would be 110 inch.
Okay, so we're into the very large LCD screen space.
Yeah.
Do you foresee a time when this technology becomes available in, for example, a more popular run rate size like 65 inch?
Absolutely.
Where do we need to get to?
Yeah, where do we need to get to? Ultimately, we need to be kind of hitting 55 inch 4K as a minimum. Yeah. So that is going to be the kind of sub 0.5, 0.3, that kind of area. All of the manufacturers are hunting that down.
Okay.
So MicroLED, or the use of an inorganic semiconductor chip that we use in all of our LED display technology, produces its own light, and it does it incredibly efficiently.
Right.
So currently your options are an LCD technology. You might use an LED as a backlight, and you push that light through a liquid crystal display and color filters, but it's not the most efficient way to deliver an emissive technology. So it has its limitations, and OLED's great. You know that you're going to get pixel off means black. You know, you're not actually using any power, great color, but it's kind of limited on the brightness it can achieve. Right. And it's limited on its lifespan. It can suffer from image burn-in or image retention because it's an organic LED conductor, semiconductor chip. So MicroLED is the best of, and better than the best of both worlds. So everyone knows that the future of the technology will be MicroLED in a different form. So some of our manufacturers are producing MicroLED, and it's called chip on glass. Yep. So it's a slightly different manufacturing technique, a lot more mature than the current pick and place flip chip on board technology that we're using. The benefit of that is they're using active matrix driver technology, TFT technology that's in current OLED and LCD technology. And it means they'll be able to mass produce and create single screens instead of tiled solutions that we're currently using. But there's still a load of technology bottlenecks all the way back up the chain of manufacturing to get the yield up and to get the cost down. So
what do you think will happen to the bezel of a display when that happens? Is there a need for a bezel when we're using MicroLED in place of conventional LCD or OLED technology? Well,
we're lucky at the moment that we drive the LED. A flip chip is you take your LED semiconductor chip from the wafer and you flip it onto the electronic contact. Yeah. And then the front surface that emits light emits 100% light to your eyes. And that's the benefit of the flip chip technology. There's no wire bond to the front face like a traditional face-up LED. So we're driving the technology from the rear side. I think your TFT technology has wires passing through, and there's connectors at the side and at the top of the display, as I understand. So I think that as we move to the sort of chip on glass solution, we will still maintain a bezel.
Still need that.
But I think we've seen it reduce, or we hopefully one day we won't have bezels, right? Nobody likes it. We're lucky now that the current flip chip on board MicroLED doesn't have bezels. Yeah. So we can present it in that format, and it looks fantastic. Yeah. So
customers wanting to make use of Pixel IQ, how do they interact with it?
Really simple. You've got to remember pixeliq.com. That's the URL, so don't forget that one, guys. Save that as your favorite, because I think if you're looking for LED, it's going to be your go-to. So the benefit will be that, you know, traditionally if you were looking for LED, you're going around manufacturers' websites and you're trying to find where their LED configurator is. And everyone does it slightly differently. There's different levels of the quality of that user interface. There's different levels of the technical output that you get. And the output and format of the data and the information, the specifications they give you of your screen is laid out differently for everyone.
Right.
So if you go off and your client wants 3 choices, you're going to have to go to 3 different places, learn their UI, figure out how it works, select from their wheelhouse, output it, and then print a bunch of PDFs, and then look between this cell, this cell, this cell, see what's the power consumption. And it might be per cabinet, and you want to flatten it out per square meter, that kind of stuff. So if you remember pixeliq.com, you're going to land on that page. You're going to be able to filter across brands, sort of narrow down your search, find the technologies that you're looking for, quickly configure to the wall size that you're aiming for, or resolution or aspect ratio, etc. And then add that display to your kind of basket, add a couple more, and then output that, and you'll get all of those specifications side by side in a consistent format. And then, as I say, at push of a button, a PSCo specialist will actually deliver a complete sales package for you and quote you that solution.
Brilliant. Is there anything that people should consider? Common cathode springs to mind here in terms of the power consumption on LED screens, and what technology customers should be looking for if sustainability is of concern for them?
Yeah, I mean, common cathode is a driver technology. So 90%, 95% of LED screens use common anode. And common anode is you place power to red, green and blue pixels, and you share the same voltage to all 3. And where typically your red LED needs a lower voltage, you use a ballast resistor within your circuit to drop the voltage. But a resistor resists and it creates heat. And that used to be a major problem for narrow pixel pitch 5-10 years ago. The pixel technologies, the driver electronics, the PCB designs, the use of flip chip technology, chip on board technology, has meant that advantage has got smaller. Common cathode comes at a premium. It's a more expensive driver architecture. With common cathode, you get a dedicated voltage for red, green and blue. So you don't get that ballast resistor and you don't get any of that inefficiency, but it does come at a cost. So it's not as prevalent as it once was. It doesn't have as big a place, but there are some manufacturers within our portfolio that do have dedicated common cathode solutions. So if you're looking for sustainability, you're looking for the absolute lowest power consumption, then we've got solutions.
Great. So it's visit pixeliq.com.